biology, physics. Right, I forgot to record it. Okay. Mustafa, are you recording it?
Yes, I am.
Okay. Yeah, we'll have to post that. Okay, so we have plenty of majors in this club. So if you're not in engineering or CS, don't feel left out because we'll certainly have a place for you. And of course, normally we hold several events. Our marquee events are usually the competitions. So this one down below, you could see is CIRC, Canadian International Rover Challenge, that takes place every year in Drumheller, Alberta. And the Rover team tries to go to that every year. We will certainly try to go next year, COVID permitting. We also, of course, hold SumoBot competitions. That is hopefully going to happen in the winter. We hold workshops, game nights, and a whole bunch of other things. We plan to have workshops virtually this year as well. I know some of you are coming from the Tinkercad workshop that we did for week 0. We're going to have other things like that too. So and now I'm going to hand over the mic to Luke if he's ready, and he can talk a little about the SumoBot team. We're going to have a lot more to talk about a SumoBot team after, but I think Luke will give you just a brief overview.
Yeah, so the SumoBot team is really focused on teaching. And if you don't know, it's a competition where you build these tiny little robots, as you see the little picture on the right. And you build these tiny little robots by hand. They meet a very small list of rules, and we build them up, and they're basically meant to push robots out of a little ring. I can actually show it. Oh my gosh, I actually got this today. The official ring. It's very small. It's only about like a meter across. And we compete. Your little robot it's the sole goal of just pushing the robot off. It's quite simple, and it's meant to be a fun club. We're gonna have like bi-weekly meetings-ish. Hopefully, maybe a little more often, maybe a little less, depending on, what workshops are being hosted that month. And yeah, that's a brief rundown. We'll go into more detail in the SumoBot meeting happening after the general meeting.
Okay, wonderful, Luke. And next we will talk about the Rover team with the staff hour team lead.
Hi, so I'm the current team lead for the Rover team. Can everyone hear me? I don't know if everyone can.
I can hear you, Mustafa.
Okay, perfect. Yeah, I didn't have any feedback to tell me if it's working or not. So I'm the current team lead for the Rover team. The Rover team is essentially a large team composed of I'd say a dozen or so, currently a dozen or so active members, and we aim to compete in international competitions. We were founded in 2007, and over the years we've competed in the University Rover Challenge in Utah, the Canadian International Rover Challenge in Alberta, and the Ontario Rover Rally in Hamilton. We've also competed at the National Robotics Challenge at the Kennedy Space Center, but that challenge is not open for Canadians anymore. This year we're targeting CIRC, the Canadian International Rover Challenge. Of course, it all depends on how things play out due to COVID. So the Rover team is divided into 4 major subteams: the mechanical subteam, the software subteam, the electrical subteam, and the science subteam. Together, we work together to build a rover that is teleoperated. That means like the operator cannot see the rover physically with their own eyes. They're kind of like put in a box and put in a metal room, and that room can be located up to 1 kilometer away. So what that means is like you may start the task site with the rover right beside the facility. However, the competition tasks may require you to travel up to 1 kilometer. So not only that, the rover also must support autonomous operation modes, so navigating from one place to another while avoiding obstacles, as well as like supporting a robotic arm, which helps with many other tasks. So now I'll go a little bit into the subteams. So the first subteam that I'll be talking about is the mechanical subteam. So it's split into a couple phases. Usually, first we work on the design. Before we do the design, we do some research based on what other teams have done, what we've learned in school. We pull all that together to come up with feasible designs. and after discussing, we choose a design that we want to go forward with, and then we model that design up in Fusion 360, which is our CAD software. Fusion 360 is pretty nice because it allows collaborative work, which SolidWorks, which is the alternative, does not, which is the reason why we use Fusion 360. Next, after it has been CADed, we look at the design and ensure that it is sufficient, make sure that it can theoretically hit all of the goals that we wanted to do, essentially doing some sort of design review. And after that part has passed, we move on to the manufacturing stage. Before that, we determine whether or not we should prototype. Prototyping essentially happens with cheaper components so that we could see the feasibility of the design before we actually spend money on the final components. And for many parts, due to how fast everything moves in the team, prototyping isn't done. However, for major things, prototyping is done. After the prototyping part, we go into manufacturing. And for manufacturing, we use standard machine shop equipment such as mills, lathes, and other things you could find in the other machines you could find in the machine shop. However, due to COVID, the shop is currently closed, and we do not know whether or not we'll be able to go in. So that part is kind of like on hold. The materials we use include aluminum, steel, carbon fiber, as well as a lot of 3D printed parts for non-structural components. That is because the rover does have a weight limit of 50 kilograms, so it is crucial that we distribute, we are as light as possible. So there are a couple of major components of the mechanical subsystem, subteam, which is like the drive and suspension, the arm, as well as the rest. So the drive system that we're going with this year is a 6-wheel rocker bogie system inspired by the Mars rovers that NASA sends out. There is no differential bar, however, it does allow us to climb over larger obstacles. In these pictures, you could see the CAD model of the drive suspension system, as well as some students who are working on that, working on physically building out the prototype last year. Now, we built out the prototype, and now we're modifying the CAD model in order to incorporate the lessons that we've learned from it. So this CAD model that you see here is not complete. So due to COVID, all meetings are done online, and that means that we won't be going into the university at all, into our workspaces to work together at all due to safety concerns. And what this means for the mech team is that all components are built out individually in students' homes. So for example, if you are responsible for a certain if you're responsible for a component, we'd have the material shipped to you. Hopefully, no major machining needs to be done. If we do, then we'll have to figure something else for that, and then you build it out and test it there. So next, I'm going to talk a little bit more about the arm, because so the arm that we're going with this year is a Cartesian Scaro hybrid arm. So what that means is essentially it's a mix of a Cartesian arm, which means which allows movement in the X, Y, Z axes. So if you tell a Cartesian arm essentially means that if you tell it to go forward, it'll go forward in the Y axis. If you tell it to go in the X axis, it'll be able to move in the X axis. If you tell it to move in the Z axis, it'll be able to move in the Z axis. So that's what a Cartesian arm is. Now we're combining it with the Scaro arm, which is an arm that holds the Z axis rigid and allows movement in the X and Y axis as well. So at the bottom here, you could see kind of a visualization of what we expect the arm to kind of not look like, but like what the degrees of freedom would look like. So we have 8 degrees of freedom in total. So we have 2 z-axes, which you could see on the rod here and as well as here. And then we have 3 rotation axes and a wrist, which allows pitch and roll, and a gripper, which opens and closes. In terms of design work, the z-axis and the rotation axis, they're currently in the design phase. Some are more completed than others, and the wrist is currently has completed design and is now in the prototyping phase. On the right side, you could see the wrist model, which uses a differential system in order to pitch and roll, as well as the prototype at the bottom. The prototype is currently under construction, and we are using carbon fiber PETG 3D printed parts for it. And we're currently determining whether or not it is strong enough for us. So next, does anyone have any questions regarding the mechanical team so far? Feel free to unmute yourself and ask or put in the chat.
Yeah.
If not, feel free to just put in the chat whenever. I'll continue on to talking and speak a little bit about the ECS subteam.
Yeah, feel free to just put in the chat or raise your hand or something, and one of us will talk to you.
Yep. So due to COVID, the electrical and software teams are going to be temporarily combined because it's basically impossible for us to work with electronics in the current environment, since it's not really feasible to break it down into much smaller parts. In terms of the software, we use the robot operating system, which runs on Ubuntu. And in terms of the languages that we use mainly Python and C++, more so Python, but there's also some C++ code base that we have. And we determine which to use based on the requirements and stuff. So the types of things that the software team works on include networking, because it does the rover does need to be teleoperated from 1 kilometer. So that means our networking needs to be very solid. If you don't have a good network system, then no matter how good your rover is, it's not going to move. A GUI. Over here in the top, you could see a screenshot of our current GUI, which is still being polished. Essentially, the GUI allows the operator to see everything at a glance and make decisions, such as where to go next, what the current position is, what the upcoming waypoints are, and all of that. There's also the embedded side, which essentially handles the conversion between the high-level commands, such as, okay, move forward, into actual actuator commands, such as turning the wheels. So that's the embedded side. And also autonomy. We currently don't have any autonomy code base because that's very new for us. So this year we will be starting to focus on that a little bit. And in that, we'll essentially be making the rover be able to move from between 2 GPS points, 2 or more GPS points, while avoiding obstacles. So we'll be developing algorithms as well as systems for that, potentially using things such as 3D cameras, LiDAR, etc. So a little bit about electrical. Our power delivery system is currently 2 14.8 volt lithium polymer batteries with a total capacity of 600 watt hours. We're currently, we'll undergo testing to see if this capacity is enough. And if it is, then we'll continue with it. And if not, then we'll beef it up a little bit more. The electrical system is divided up into multiple circuits, high power circuits and low power circuits, each separate and fused. And we use mainly off-the-shelf components such as motor drivers, motor controllers, and that, mainly due to the simplicity and ease of use. So that means, unfortunately, we do not make our own PCBs at the moment. However, that may be something that we can look into in the future. So moving on to the science subteam. Before I start with the science subteam, does anyone have any questions regarding the ECS subteam? I see a question here. How many hours each week do you think we need to commit to each team? So in terms of sub-teams, you can join one or multiple. Most students usually prefer to join one and focus on that. And it all depends. Generally, you could spend up to, I'd say, 5 hours a week would probably be a solid amount in order to fix your tasks. However, that does vary based on workload as well as like what stage we're in. For example, if we are in the real beginning stages, then it's a little bit slower. However, when it comes to competition crunch time, then the workload goes up a lot higher. All right. I'll talk a little bit about the science sub-team now. So the science sub-team essentially focuses on soil collection, soil analysis, terrain analysis, and research. So we collect soil and then we apply tools such as pH test. We analyze the soil using either off-the-shelf components or like things that you do in a lab, such as using like maybe as simple as like litmus paper or hardware components such as Arduino pH testers, etc., to determine what organic content are in the soil. This interfaces with our software system so that the science students can generate a report that talks about how habitable the area is, as well as like what the soil implies. For example, does it imply that there's life there, etc. So essentially, they work with both the software and mechanical subteams in order to collect soil, analyze them, and also analyze the surrounding environment in order to generate a report that the competition judges read and grade. In the past, we've traditionally done pretty well in the science tasks, and yeah, we hope to continue that forward. There's also a lot of like working on the science sub team also gives you access to kind of, it's like very multidisciplinary. If so you work with a little bit of software, a little bit of hardware, and it all comes together on the science sub team. So if you kind of want to dabble on a little bit of everything, if you're like a biology major or something, then the science sub team may be perfect for you. So moving on, it's kind of like as a conclusion slide. So the robot team essentially, it has a huge learning curve. However, motivation is key. If you are motivated, then you'll be able to easily overcome those obstacles and learn new things and complete tasks, and also attend competitions. So we have frequent weekly meetings for most subteams, particularly the ECS as well as the mechanical subteams. It's a very large commitment, requiring anywhere between 5 hours a week to, I would say even, 5 hours a week to 7 hours a week on average of work. However, it's very worth it in the end. It's very rewarding to see like the project succeed. Over here, you could see examples of competition tasks. On the left, it's the equipment servicing tasks. In this task, the rover is required to refuel the generator as well, and then is required to diagnose any issues with the generator and press the buttons and flip the switches in the right order to fix it. And on the right is an image from the search and rescue task. In this task, which took place at nighttime, there was we had to use radar direction finding. We had to locate a stranded astronaut and then deliver oxygen bottles to them. And we did not know the location of the astronaut. We had to locate the astronaut using the strength of their beacon, essentially. So they had a SOS beacon, and we had to kind of move the robot around and figure out where it is, go closer, and that. So the robot on the left is not ours. It's probably some Polish team. The rover on the right is ours from Cirque 2018. So yeah, that pretty much concludes the rover team content. If anyone does have any questions, feel free to ask them.
Yeah,
I know
please
it's I know it's a lot of information that I just threw out.
Yeah, please feel free to post questions in the chat or even to unmute yourself and ask something. Anybody have any questions for about the rover or SimoBot?
Hello.
Hi.
I just had a quick question. So, like these like tasks and stuff. So, like when we go to competitions or like the materials and stuff needed for the rover, is this coming like from the school or like a sponsor, or is this coming out of our pocket?
No, it's materials for rover are coming in from the club, so you don't have to pay. I mean, you don't have to pay for anything.
Yeah. Okay. Thank you.
If you go to competition, only incidentals. We try our very best to cover everyone. Only incidentals you'll pay for is your own food and whatever.
Okay. Thank you.
Any other questions?
If not, make sure you join the Slack because we do use Slack as our main communication platform. We're going to be sending out a poll tomorrow, later tomorrow, regarding meeting times, as we'll be resetting, as we'll need to figure out what days and times we'll be holding our weekly meetings. So make sure you join our Slack and keep an eye out for that. And then depending on which sub-team you join, they will also be having like introductory meetings, like the first couple meetings for those will be introductory. So another thing that I forgot to mention is if you don't have any experience, that's completely fine. Me and Adam joined with no experience whatsoever. And as long as you have like the drive, you'll be able to like get over the learning curve.
Nan, do you have any questions, Adnan? We will continue. So if technical side doesn't interest you, and honestly, for some people, it really doesn't, well, you're in luck because we actually have a lot of non-technical roles. So aside from our two teams, we have held Krispy Kreme donut sales in Central Square. If you're a returning student, you may well have seen us. We usually have a big table right at the entrance to Berry Hall, the whole connector. You may have seen us. You may have even bought donuts from us. Unfortunately, it's probably not going to happen this year for obvious reasons. Hopefully, you'll see us next year, the year after, and the year after, and the year after, even though we may not be there. But aside from that, our sponsorship teams and fundraising team, our sponsorship and fundraising team is very active in seeking out potential corporate sponsors. There are many roles available in our sponsorship and social media teams, and in fact, we are planning for a very active social media presence this year. Our social director, Ibrahim, is on this call, and if you want to speak to him, you could DM him if you want. As well, you can get a sense of how complex a large club is behind the scenes. It's also a great way to get into the administrative roles if you are interested in that. Our administrative positions are actually elected for the most part. So if you really ingratiate yourself to all the admins, you'll probably do pretty well. Well, there are several reasons why you'd want to be involved in YRS. First of all, it's really fun, like really, really fun. It's a real engineering project. It's a real, you get to work on. It's always fun to see the results. And even if you're not in engineering, I think everybody can get a sense of how things work. And it's, of course, just a hands-on thing, even if you don't really care for the design process. It's really fun. Like everybody has, everyone has a role to play. Don't feel left out. And there's certainly no shortage of things to do at YRS. Second of all, you can learn new things. Robotics is a really broad field. It's expanding. It's going to be huge in the future. It already is pretty big now. There's always something new you can try. Third of all, you get to meet new people, both within and outside of your major. And I've personally met, several dozen friends this way. And I think the people I want to work in Capstone, if you're an engineer, you know what Capstone is. I met most of them at YRS as well. First of all, I personally find that if I can't apply what I learn, it's a little pointless. I mean, it's just learning for its sake, but it's not nearly as cool as if you could apply it. But YRS finds a way so that if you learn, a bit of programming, if you learn a bit of design, well, you can apply it here. There's a lot of room, especially in SumoBot, if you want to make your own design, if you want to give your own flair to your own robot. SumoBot gives you a wide latitude. And finally, it looks really good on your resume. If you're in CS and Eng, 95% of YRS members that search for a co-op and internship position have gotten one, including at the companies you see here. I personally just finished a co-op at IBM, and Mustafa is currently in a co-op at Geotab, so we certainly have a lot of experience there. And of course, that concludes my presentation. After this, we will be transitioning into the SumoBot meeting. If you want to contact us, if you are interested in joining something like Rover or SumoBot, the links are here in the description below. I think Mustafa or Luke should copy them into the chat. yorkrobotics.com/join. We've got a Google form. If you filled it out already at the Tinkercad workshop, well, you're good. We probably sent you an email already. And Slack, join our Slack. We are, that's most of our communication takes place on Slack. We'll have weekly meetings and bi-weekly meetings on our campus groups as well, but we highly encourage you to join Slack. You also can find us on social media. You can just search up York Robotics. And yeah, I think we should get building.
Yeah, so just so everyone's in the clear right now, we'll be transitioning over to a SumoBot meeting, the first of many. If you are interested in SumoBot and Rover, you can always join both. But if SumoBot is not something that interests you, then join our Slack and keep an eye out for updates, because the next meeting will be taking place soon. Date has not been set yet, but it will be within the sub-teams that you're interested in. So if you're interested in any sub-team, make sure to join and say hi in the relevant channel so that we are aware. So yeah, Luke can take it away now for his SumoBot general meeting.
All right, I guess let's get right started. Make sure to have your computers out. There's going to be a lot of links we're going to be sending, and we're also going to, after we get through kind of like the initial introduction, we're going to go into a tutorial. So some of you have probably done it before at the week 0 meeting that we had a few weeks ago, but so you don't have to stay for that. After our next meeting, we'll go into some other stuff, other topics, such as sensors and whatnot. So yeah, what is this club about? We're basically, all of us, I'm going to lead you guys through the steps of building a SumoBot from nothing, knowing no programming, knowing no CAD at all, no electronics, and we're going to build all the way up to building one of the SumoBots that you see on the right. And we're going to learn the basics, and if you already know the basics, you can challenge yourself. You can add more sensors. You can modify it. For example, this SumoBot here, we have a nice those orange wheels there. Those are pretty expensive wheels, but they're much better. And you can modify your robot how you see fit. You can do upgrades such as that if you want to really challenge yourself, or you can opt for just like the cheaper, get it working, just to learn. And this competition is supposed to be held in winter 2021, but we all see those case numbers. It might not happen, but that's beside the point. The point really is to learn, and there's really no pressure to compete if you don't want to. So some of the rules. There is a handful of rules if you do want to compete. So there's a strict rule of 10 centimeters by 10 centimeters. And the way they test that is they get a little square, like a little square box, and you slide the robot in. So it can be as high as you want, as low as you want, but it is restricted to the 10 centimeter cube. And this robot here, it's almost precisely 10 centimeters by 10 centimeters. It is really on the edge there. And yeah, the goal is to fight other robots. You saw earlier, I lifted up that ring. it's a 1 meter ring, and it's 2 tones. So the outside is one color, white, and the inside is black. So you take advantage of that with your sensors and whatnot. So you can see if you're close to the edge or whatnot, and you can program the robot to do other things based on that. Just a quick little demonstration. Hopefully this is at a relatively good frame rate. You see the robot just simply pushes it right out of the ring and it wins there. And that robot, that was our robot that won in 2018. I want to say 2018. Yeah, all right. So they're going to be bi-weekly meetings that are covering every topic, as I said before, and we might do more if requested if people are stuck on a certain component. For example, the Fusion 360 CAD component, it's probably going to be relatively difficult for some if you've never done any CAD like that before. So it's going to be a friendly environment. So there's going to be a lot of chance to ask questions. It's not going to be all teach, lecture. That's lame. Nobody wants to sit through that. So we're going to keep it that as minimal as possible. And if you can't get something working, I'm going to have all the answers. Basically, I'm not going to just say go do the robot. Oh, you can't do it, sucks to be you. I'm going to give you CAD documents and code that's already working. So if you get stuck, you can just copy it, because it doesn't really matter in this situation at all. Are you guys answering questions in the chat? I haven't watched. Adam, Mustafa.
Yeah, we're handling
we are.
the chat.
Yeah.
Don't worry.
Okay, good. So parts. So in the past, we've had a lot of chance to basically you borrow kits. And of course, with COVID, we can't exactly do that in this situation. So we're gonna turn it on its head a little bit and ask you guys to purchase your kits yourself. But this comes with an advantage where you get to keep these robots and modify and use them as much as you wish. And this can, for people just starting out, this can boost you right into the tinkering kind of realm, hobby, if you want to do such a thing. And they're relatively cheap. We don't recommend it at all, but you can split the cost with a friend as well. They're relatively cheap in the sense that they're about, so far my math concludes that it should be about $60 to $80 per kit, but it can vary depending on if you want the more expensive wheels that I previously talked about, the more expensive sensors, and more batteries, because there is a weight limit actually of about 500 grams. But if you push the edge of that, it can really give you an advantage. So just for click, we're gonna add a little link to the chat real quick. This is just a survey to ensure funding and whatnot, to ensure we get our funding for 3D printing. So one of the other aspects of acquiring parts is a lot of the actual base for the robot, actually I can get it over here. Hopefully you can see the camera. A lot of the robot is 3D printed. So a lot of people don't exactly have 3D printers. So yeah, so what we're going to do is we're going to allow you guys to send your CAD documents to us, and we're going to 3D print them for you. We'll have some kind of handoff system in place, but I actually, in my room here, maybe you can see it. We can see it. There's 2 3D printers sitting right there, ready to print all of your stuff. And yeah, if you wouldn't mind taking a second to take that really quick survey to ensure that we get all the funding we need for the 3D printing, and to ensure we can prove to Lasan that, hey, people, how do I describe it? It helps us a ton to fill it out, to put it simply. And
Yeah, essentially it allows us to have a bigger picture, have a better picture of what you're capable of doing. Like if you already have soldering equipment, if you already have a 3D printer, if you can afford parts or not, what parts you already have. Having all that information allows us to better provide for you, essentially. It helps us to shape what we're going to be doing in the future so that we could tailor it more towards to better serve you guys.
Yeah, exactly. So we're going to paste that in the chat. that chat, that second link, which is just the string of letters and numbers, basically, this is our meeting time survey. So in terms of meeting time, I don't know what most people's schedules look like. I can't memorize that. Nobody can. So I am going to put it up to a vote for when our next meeting should be, which is going to happen sometime next week. I kind of want it to happen kind of quickly, just in the situation. The meeting in terms of time will be, I want to go for an hour, but definitely you don't have to stay for the whole time, and I'll just continue answering questions and helping people out until I need to do my own stuff eventually, which should be like, I'll allocate like 1 to 2 hours for these meetings. I'm preferring around 7 p.m. for my own schedule. I have stuff, earlier in the day. I have other stuff to deal with later in the day. It works out for me. Any weekday, you'll see in the form, there's like any weekday basically. And if you want to fill that out, that'd be amazing. And I'll probably take either the first or the second choice in terms of most popularity if something comes up for me, and I'll announce it in the Slack group well beforehand, as at least 2 days beforehand, at least, but hopefully give more heads up than that for these meetings. And there'll be a Zoom link and all that. It'll be very easy to join. It will be kind of like this. And this is all for a SumoBot team. I see in the chat there. All of these links are related to SumoBot survey and a schedule for the next SumoBot meeting. So yeah, I guess one thing is for the SumoBot parts, I will provide a link in Slack, not so much in this chat, which will have this spreadsheet. It has a list of options that you can select. There's cheap options. You can see it kind of faded in the background. There's cheap, expensive options, medium options. And one of the key components that I want you guys to know is that there is this option for Arduino kits that you can buy online. And since a lot of these parts, you can buy like 100 of them, LEDs, and 100 light sensors at a time, but they're like $10 here, $10 there, it adds up quickly. So with these kits, you get like 5 LEDs and 5 light sensors is what you need, and like a 9-volt battery and a couple buttons, and you only really need that much, and therefore it lowers the price of these kits. So these kits are about $30, $40, and they have about 50% of the items that you need to get started with these SumoBot kits that you buy. And yeah, about here, I can answer any questions that you have, and we're gonna move into the Arduino tutorial next. So we're gonna use Tinkercad on your computer to create a little motor driver circuit.
So just a quick thing regarding Slack. Slack does have a bad habit of not giving notifications, which some people experience and others don't. So with that in mind, that means you do kind of have to be aware of that. Sometimes if you don't use Slack for a long amount of time, for example, 2 to 3 weeks, then it won't give you any push notifications. So just make sure you check Slack every so often. And I highly recommend downloading the mobile app so that you can see all the notifications come up on your phone. As well, the desktop app is not as important as the mobile app, because in desktop you could just go to the Slack website and allow notifications from there, which does the job, which is what I do essentially. So yeah, that's just the thing with Slack. Why do we use Slack over something like Discord? Essentially, our membership base prefers Slack over Discord due to its features such as threads, and it's just a little bit more professional, I guess. I don't know.
But, yeah, I don't know about you guys, but my Discord profile is a little bit of a meme. Not gonna lie. Prefer not everybody see that for professional stuff like this. I assume everybody else could agree with that. As somebody asked in the chat, are we constrained to the materials on the Excel sheet? And that's definitely not. You can choose whatever you want. It's just simply a guide, because I assume that some people here just have never done any robots before. So I should probably open it up. I'm gonna stop sharing for a second, just for a second, and I'm gonna open that spreadsheet up, and I'm gonna explain a little bit more about it because it's a little bit complex try and make it colorful, but of course, it's not always the case. Can't always help. All right. Okay, so basically to buy everything that you need, you just need one item from every single category, and there's each color is a different category, and you just need one item from every category, and that should include everything that you need to build your sumo bot from nothing to a full working sumo bot. Of course, this includes everything except the 3D printed parts, which again, if you wanted to, you could definitely make yours out of whatever material you want. But you basically just need one from every category. But of course, these kits come with some of these items that already fill out these categories for you, which of course you have to, do the math, figure that out yourself. We're trying to make it as easy as possible, but we were going to consider the option of you just buying a kit from us, but unfortunately the logistics are just way too complex for us to do that. And this is probably the easiest method. And yeah, I don't think, are there any questions about the spreadsheet? Because I know it's a little complex, and I could just get a link and share it so everybody can view it on their own right now. I was going to post it after, but it might just be better to do right now. I think everybody can just view, right? Anyone can view. Okay, let's just do that. Come on. Chat. Okay, that link there, it'll take you right into the spreadsheet. You can just check it out, view.
Excuse me, I had a question. I had a quick question.
Yeah, go ahead.
So with the kit option that you said, what are involved in that kit? So how do you know which items remain so we can go and buy the other stuff?
The kit option. So so on Amazon, if you go and search Arduino kit or robotic kit, I should have probably put the search term in somewhere. Oh, it's there. It's there as a URL to the right. There's a million different kits out there, and they're always changing, they're always cycling. So I didn't want to link to any specific one, but all of them have huge photos on them, which tells you every single part that comes with them. And you'll just basically have to go and check mark, does this kit have everything I need? And is it a decent price and it doesn't have too much? A lot of these do, as a note, a lot of these do include an Arduino already, but it's actually a slightly different model of Arduino than what we're looking for. So do I have one? I do. So usually a lot of them come with this larger Arduino here. This is an Arduino Uno, but we're not going to use that because it's just too big. If you see the SumoBot here, there's just a tiny little microcontroller there. That's the Arduino Nano, which is what we're actually going to be using because fortunately this thing is just way too damn huge. But yeah, the kit option is really just a search query. It's just to help you out as to get cheaper, way cheaper. You can save a ton of money just doing that option. Yeah, if you're splitting costs with people, you could go and get the $10 option with 100 LEDs and easily split and save some money there. I also provided some AliExpress links. Those are kind of, in terms of shipping, it just takes a lot of time, but it's really to show you that there are cheaper options out there. And if you're willing to pay for express shipping, I think maybe you could still save money instead of opting for Amazon. But yeah, I encourage all of you to ask questions in the SumoBot chat. Hopefully you can order them soon. I know probably you're still a little hesitant, just introduced the SumoBot Club and launched right into it, but yeah. Is there still any other questions? Because I think we can move on to the tutorial soon.
Just wanted to jump in and talk about like the parts list. The reason why there are part differences, I'm not sure if it was mentioned, is because some are just higher quality. For example, I'm not sure if there's multiple wheels on there or, for example, multiple motors. Like one you'd see is like, it doesn't have as good specifications, like it's not as powerful. However, if the main goal here is to just learn, and get the experience. And for that, it's perfectly fine. But if you're a competitive person and you really want to win, then you'd want to spring for the more expensive option. So that's pretty much the only difference. And also, the other thing is, if you do find a kit and you're unsure of whether or not it includes the item, after compare it against the other ones, you could feel free to send it to Luke, and I'm sure he could help you out with that.
Yeah, just send the Amazon link right in the chat. You can message me directly if you want. And yeah, I can just definitely check it out with you, because I bought like about 3 of those kits myself over the past couple years, and I kind of know what they kind of come with. The photo really does tell you a lot, but of course, feel free to ask. And I guess this is the point where we got to do the attendance part. That's the annoying part that nobody likes. But Lassonde asked us to do it, so we kind of got it. So yeah. Copy and paste. So if you could just fill that out, it's so Lassonde keeps track of what clubs are doing what, how many people are attending these clubs. They asked us to do it. Kind of annoying. Kind of feels like we're in grade school, but we're not. You could fill that out real quick, and that's in the chat. So we could just, another link we're going to put in the chat. We're going to start with, I guess, the tutorial. Whew. Should I give a pause for a second? Maybe. I guess we could start with like, you're going to need to go to Tinkercad. Yeah, and this is the attendance link, and then this is link to tutorial PDF. You can download that, and that I'm going to follow through along with myself, and we're going to probably just wait. Everybody can create a Tinkercad account. Probably wait 5 minutes, take a break for a second, and then we're going to launch into the tutorial. Yeah, I'm going to go to Tinkercad right now. Again, you can ask any questions while I'm just sitting here.
I have a question.
Yeah, go ahead.
So it's like in my high school, I have participated in one of the competition, robotic competition, and they just bring the robot kits to us, and they show us how to assemble it and what are the basic components. So I was saying that whether that kit would work or not in this program.
You're a little cutting out a little there. Could you speak a little louder?
I was saying that that kit that they have given us would work here or not.
How the kit would work?
Yeah. Yeah.
Like the, are we talking about the Arduino kits that I told you to buy to like kind of cut your cost in half, or?
Yeah, it was like an Arduino, and it was having 2 sensors of detecting black and white strips, likewise.
Oh, I forgot to explain that part. The sensor for the black and white. So how there's a janky way to do it that works actually quite well, and there's kind of a more formal way of doing it. You can use some more expensive sensors that you can buy are optical, or included in these kits are not that. This nope. Where was it? Light sensors. So photoresistors you can use along with an LED to help it out a bit. You can use it to detect black and white because it's contrasting, it's brighter and darker. You can use these little photoresistors, which if we open the Amazon link, actually, we should be able to see it. And they look like that. And those are what used to detect black and white. I hope I'm answering the question. I hope so.
Yeah. Sure.
Okay, good. It was a little hard to hear. I apologize, but hopefully I got your question. Yeah.
Just to ask, how many of you have been a part of our week 0 tutorial.
Okay, I'm gonna open up the PDF now. So, okay, so does everybody have created in a Tinkercad account and have the PDF ready to go? I guess you can raise your hand, question mark? That's a thing, right? Using the little Zoom feature. If you've gotten it all ready to go. Of course, if you've done the Zoom thing or the week 0 thing, you definitely don't have to follow this tutorial. This is kind of our first initial tutorial. If you find this interesting, you can definitely continue with SumoBots. And our next tutorials will cover more sensors, such as the ultrasonic sensor and a few other things. We're going to do ultrasonic sensors, I think, and photoresistor is the thing I answered the question earlier about, and how we're going to use that to detect contrast, so we know we're at the edge of the mat with the SumoBots. Okay. Yeah, it seems about like half have done it so far-ish. I don't know if everybody's going to follow along exactly or we're just going to watch. It's definitely up to you. Yes, for people leaving and have class, you can definitely follow the PDF on your own. I put a lot of detail in it, so it should be able to allow you to do like everything all the way through. And yeah, you can do everything all the way through. And if you find that interesting, definitely you can also come to me and ask, because there's example code and everything in it. The PDF, it's back up in chat a little bit farther. The attendance link, tutorial PDF. Can I resend it? There we go. All right, I guess. Yeah, we can get started then. Okay, so assuming you have the account already, we can go right in. So I'm just going to work through it with the PDF. You can use the PDF yourself, and I'm going to work through it with you guys so you can see. And then after this, after I assemble it all and explain some bits of it, we can definitely ask questions. We can modify it as we wish, if you would like. So let's start off. We're in the Autodesk, we're in the base. These projects wouldn't exist for you. These are just what I used to do the week 0 tutorial and previous stuff. But we're going to create a new circuit with this button, green button. Well, actually, first on the side, we have to select circuits on the left, and then we can create a new circuit. And once we create that new circuit, you're basically launched into this. And it's a lot of buttons. It is a lot of buttons. So on the right side, we're gonna basically select, components. We're gonna move from basic, we're gonna move right up, and we're gonna collect all. So it has like everything we need in it. And what we're doing, if it isn't obvious for everybody, we're gonna use an Arduino, and we're gonna use a motor driver, and we're gonna control a couple motors and make them spin. We're actually going to control only one in this case, but it's very easy to add a second one if you know how to just at least do one. So we're going to start with adding the Arduino. So what we can use, we're going to use the search tab a ton, and we're going to search for each part. We're going to drag and place, and then we're going to start connecting everything only once everything's placed on the our little workspace, as Tinkercad likes to call it, I think. So Arduino, Arduino R3. This is the big one that I showed earlier. Same thing, just blue. And then we're going to add a 9-volt battery. Autocorrect. And what you can do, if you're dragging, you can press R and it'll rotate whatever item you're dragging around. Very helpful. And then we're going to add our L29. So what this is, if you saw on the rover, or not the rover, the little sumo bot, there's a little motor driver. This is just a chip, but in essence, I can't even see my own camera. There's a little red board here. It's a little square. It's a little board that you connect to the Arduino. And that's what this chip kind of represents. There's actually, that exact chip is on this board, but it has a ton of extra circuitry so you can connect it to it easier and design your robot with a little less soldering. But this represents basically the same thing. You don't need to worry too much. And then we're going to actually add the motor. So yeah, once we have all these parts out, if you hover over the pins on the Arduino, you can see that they highlight and tell you what each one does. And same with the 2 pins on the battery, same with all the pins on the chip and the motor. So we have everything, it's really simple, 4 components, and we're all going to connect them all together. So the reason we have this 9-volt battery is because the Arduino, it's powered by your computer with a little USB, but it doesn't supply enough power to spin the motor. So we need to power it with a 9-volt battery. So we power the chip with a 9-volt battery, and then the chip does all the power and pushes that power to the motor. So we actually need to power this chip by first taking the negative of the 9-volt battery and connecting that to ground of the chip. And we're also there's actually 4 grounds. See if you can find them all. We actually need to connect them all together, if it lets me. Do we actually need, okay, it is a simulation, but in reality, you would connect all of these together. That's just electrical engineering side of me is telling me to connect them all.
It's good practice.
Yeah.
In terms of connecting the grounds of the chip itself together, you don't need to because they're internally connected to each other, but you can always do it if you want to.
That is true. You do if you were to design your own PCB though, you would connect them all together because the ground pins, they actually use to suck the heat away from the chip, which is a funny thing. But that's like ultra advanced. We don't need to worry about that in SumoBots. I'll just leave that there. And we're also going to connect the ground of the, we're going to connect the ground of the Arduino also. There's a little pin, G and D is ground. That's standard in electronics. So once we have all the grounds together, I'm going to change the colors so everybody can follow along. Of course, Tinkercad doesn't like when I select and change all the colors. It does not. Now we're going to actually connect some of the, we got to connect the battery, finish that. So there's the positive of the battery, and we're going to connect that to power 1. And power 1 is basically, I haven't told the tutorial. Power 1 and power 2, one of them's for powering the chip logic, and the other one's actually to basically bypass and power the motor directly. So I actually need to relook at that because we're going to scroll all the way down. Yes, power 1, I was mistaken. That was wrong of me. So there's power 2 down here. The 9-volt battery goes to power 2. So this is what actually powers the motor. So this voltage can vary a ton from like 6 volts all the way up to 12 volts, as long as the chip supports it. And this is what control basically gives power to the motor. But this power 1 has to be 5 volts because it's basically, it powers all the, there's basically a little chip inside of that, or there's a little microprocessor in it that needs to operate inside of it. So we're going to connect that to 5 volts here. I'm going to make that nice and red, easy to see. Same with this one. And yeah, I'm basically going to continue following the tutorial. We're going to connect everything slowly and surely. So we have output 1. So funny thing about motors is it doesn't really matter which pin you connect it to. It basically, the only thing that changes is it reverses directions. So I can connect output 1 to either positive or negative, and it doesn't change much in relatively speaking. It won't blow it up or anything like that. So I'm looking for output 2. And we're going to take advantage of both input or output 1 and 2, and we're going to use input 1 and 2 because this thing can actually control 2 motors in 1 chip. And yeah, I mean, I should probably switch these pins, make it look a little nicer. Of course, it doesn't want me to. I'll just leave it like that. It's fine. And we're gonna color these both the same color because it really doesn't matter if you cross them or not, as long as they're not like connected together or shorted together. As long as one goes from output 1 to the motor and another one goes from output 2 to the other pin of the same motor, you should be good. And now we're going to use enable 1 and 2. We're going to connect that to one of the pins. Again, I forget based on the code that you guys were given which pins go to what. Okay, we're using pin 9. So enable 1 and 2. So what this does is basically turns on the chip. It says it tells the chip, the Arduino tells the chip, hey, you can spin the motor based on the other info I'm giving you. So it allows the chip to turn on, because if this line is not on, motor won't spin. So now we need to use the other pins. I apologize if you guys are getting nauseous from this spinning. 6, we're going to use pins 6 and 5. And notice that they have a little tilde on them. This is actually important for later. Input 1. We use this one for input 1. And then we're going to use this one for input 2, which is over here. Try and make this look kind of pretty. But again, the tutorial I spent hours on making it all pretty and stuff. It was a time sink versus this is spur of the moment. And again, these ones, as long as they're not bonded together, you can switch up input 1 or input 2 because again, it doesn't really matter. But the enable line does have to go into a specific spot. And yeah. Surprise, surprise, everything's connected already. It was that simple, for one motor at least. And now for coding wise, we're not going to go into too much detail in this tutorial, but what we're going to do is we're going to simply copy and paste the code from the tutorial because it's a little bit easier at this moment in time. Definitely next tutorials when we go into sensors and stuff, we are going to jump right into coding, and it's going to be a much heavier focus on the code because with sensors, it's as simple as connect 4 wires to your Arduino, and it kind of just works if you're ignoring coding, but we need to work on that especially. So to get to the code portion, there's a button in the top right. We click on that. It's in Scratch mode. We're not going to use Scratch. We're a little past middle school here. So we're going to move up and we're going to click on the block section and we're going to click on text. This brings us into Arduino, which is the language that we're going to use to code all our SumoBots and all of that. And we're going to build up from there. So I'm just going to steal the code from the tutorial. We're not going to, I'll explain more a little bit, definitely, but it's really as simple as copy and paste at this time. And for those who want to challenge themselves, you can definitely modify it, see what you can do. We're just going to copy paste. It didn't save all the line. It doesn't look very pretty. I'm gonna fix it up a bit. Hopefully when you guys paste it, it will look a little prettier. Probably not, but yeah. We're gonna just clean it up a bit just so you guys I can read over it nicely, but this should work right out of the box. No modification required. I guess once you see it work, you can definitely modify it to your liking. Did it not work? I don't think it did. Oh no. It is kind of sad. It didn't work. Did I wire something up wrong? Well, of course, now we gotta fix it. I have to work through it and get it to work. So in essence, the way this code works is these define statements up at the top, they work like a find and replace, so we can replace it. It's just the pin number as you see them match up at the bottom in the Arduino and Uno, because that's what we're programming with this. We're programming the Arduino to tell what the other stuff to do. So basically the way void setup works is it basically all the code that you put inside of these curly braces, be it whatever commands you want. In this case, we're only doing 2 commands here. It only runs once, which is very key. So we basically saying, there's the issue right there. The code didn't copy and paste correctly. There we go. And then pin node enable output. There we go. We're using 4 commands here. So all of these, basically it tells it's pin mode. So you can use any of these pins as input or output or whatever you wish. But in this case, we're all using the Arduino as 3 outputs. That's going to be D5, D6, and D9. And we're just, these 3 lines of code basically tell you, hey, go set these all to outputs. And then this one, the digital write, is what we actually use to basically tell the green line, since we're doing the enable one, as we defined up there as 9, we're basically telling this to enable the chip. So we're switching it to high. So that means this green line here is actually pulled up to 5 volts, which for those not into electronics, it basically means the Arduino is acting like a battery and basically acting like a 5-volt battery per se, and connecting the ground and pin number 9 to the positive of the 5-volt battery and the ground to the negative of that 5-volt battery. And it allows current to flow through this circuit in a nice little circle. And when you do enable low, it's basically connecting, it keeps the ground connected to ground, but in this case, it also connects this pin number 9 to ground as well. It kind of seals them together when you replace high with low, as a way to put it. Hopefully I'm not getting too complex with the code. Somebody can tell me to slow down if I am going way too fast. And again, you can go back up with the tutorial as well. So yeah, we're gonna move on to void loop. Also, don't ignore what void means. We're gonna touch on that way later. But for Arduino C coding, you have to do void loop and void setup. So void loop is basically all the code that you want to run over and over and over again until you unplug the Arduino, basically. So anything inside of these squirrely braces here will run over and over and over again. It starts at the top, slowly iterates all the way to the bottom, and then starts again at the top and continues like that. So I can see some flaws. Again, copy and paste errors cause that. And we're going to put this here, put this here. And yeah, you can also read some of these comments. Hopefully it explains more, but we're going to jump in. Hopefully this simulation should work now. It does work. There we go. So the loop part is where it gets a little funky, because we're going to tie into what PWM is and how basically the Arduino is telling the motor driver to actually turn on, and what is it doing. It's got to communicate somehow, and we're going to talk about how is it communicating it really. So pretty simply, like a light in your bedroom, you turn it on with a switch and then you turn it off. There's really no dimmers, ignoring dimmer switches for a second, there's really on or off. And with an Arduino, you also have that is your really only your choice. With these digital pins, you really only have the choice of on or off. And if you want to vary the brightness of the light, or in this case, vary the speed of the motor, you kind of have to get a little funky. So hopefully these slides, I can use these slides I have here. Hopefully you can stare at my screen for just a second. There's really, you really only have a choice of either on or off. As I explained with that little analogy of a 5-volt battery connecting to the pin, or just completely ground it out. So to vary the speed of the motor, what we have to do, so what you want to do is you have to pulse on and off really, really quickly. And using this little visual guide here, you can, how long you have it pulsed on and how long you have it pulsed off will define how fast the motor is going. So full speed would be on all the time. 50% speed would be on 50% of the time and off 50% of the time. And we use that to vary the speed of the motor using a digital microchip. And this is known as pulse width modulation. And we're going to use that a fair bit here, especially with motor speeds, especially if you want your robot to go forward and turn while one motor is going slightly fast, slightly slower. It's pretty important that you have varying speed motors. So what we do in the code is do an analog. So we first have to connect to a pin that has the little tilde. It says here digital and in brackets PWM with a little tilde. Because not all the pins support PWM, because it's a little bit of a fancy feature. So what we do is analog write motor A, which is we set up here as pin 5. And a motor B, we're also going to set with a value. So 0 for motor A, and motor B, we're going to set with 128. So this sets it to 50% duty cycle, like I said before, where it's on 50% of the time and off 50% of the time. So the motor should go to 50% speed. And if we start it again, you can see it's about 120 RPM. I think we can get it up to 220, 200 RPM if we max it out. So the reason we're doing 128 and not 50 or 100 is because of the way the Arduino works and the way it understands numbers. Is basically minimum is 0 and the maximum is 255. Kind of a little funky. It's kind of a little weird in how it works, but it's, once you take later courses in circuits and whatnot, you'll quickly understand. It's like, why wouldn't you do it that way? Anyways, analog write, we have to, it's probably a little weird that you see motor A is 0 and motor B is 128 because of the way this controller wants information passed to it. So in the tutorial, if we scroll down, kind of a little into the bottom, you see this little table. So basically it only, if both the pins are low, you get pin 1 low, pin 2 low, and, or if both of the pins are high, you get, it's also gonna stop. The motor's not gonna spin, in essence. I'm sorry, I'm mumbling my words a little bit, but forward, if you want the motor to go in one direction, in this case, I'm using the notation of just forward, you would pull one of the pins high and the other low. And if you want to reverse the direction, you would kind of switch that up. if we're all following. And so what we're basically doing to go in one direction is we're setting this motor A to be basically 0 all the time. It's always off, it's always ground. Similar to this PWM, one of the pins is just always 0 volts. And then the other pin, we basically flip from 0 volts to the 5 volts, and then do that rapidly with the PWM explanation that I did. So on, off. So we're basically switching from stop to forward rapidly. And that's what gives you the kind of varying speed. So stop, forward. Of course, this is happening at about multiple thousand times per second. So the motor, of course, keeps spinning between that stop and that forward because it has momentum. So we take advantage of that and we vary the speed. And then basically the rest of it is pretty self-explanatory, where we wait for a second using the delay command because this is in milliseconds. And then we stop the motor completely, and then we wait a second, and then we start the motor again. So when we run it, it goes, it stops, it goes. We can see with the little RPM thingy going on here. And I guess at this point you can ask questions. I might modify this in a few minutes, see what else it can do. Yeah, so to switch the directions, you would basically, you have to stop the simulation if you want to edit it, but you change this to 1, 2, 8, and you would turn this to 0, and that would flip the direction because now the other pin, so according to this diagram, we're going from stop to backwards very rapidly. Stop, backwards, and again, this motor keeps spinning and it basically goes in reverse direction. Yeah, why are we using 2000 milliseconds as our kind of cycle time? This is just an example where the motor's on, motor's off. It can show that you can actually change the motor and we're not just turning it on. It's more of an example for tutorial purposes. If, for example, in the SumoBot competition, well, basically all you have to do is press a button. It'll just move until you pick it up and unplug it. Motors, and you adjust your program so instead of stopping after a second, you'll stop after it senses something, or reverse directions or whatnot. And yeah, anybody can ask any questions now. You can unmute your microphone, ask in the chat. Hopefully everybody's getting it. Again, a lot of people are coming from a whole range of different backgrounds. So I'm just trying to cover everybody's bases here by taking it nice and slow. And then we'll slowly ramp up as you get more experience with Arduino and so on. Is it going to be remote controlled? That is a good question. I initially thought this as well, but it is not. They're going to be completely autonomous. So basically, at the beginning of the competition, you set your little SumoBot on the board. You just put your hands on it and you press a button, and after, I think there's a delay, specified delay in the specifications. After a few seconds, it'll go do its thing. No controls, no nothing. Hands off. So this is why we're learning about sensors, so you know how to do it, and we're not just learning about motors and how to get a remote control working. So it knows how close it is to objects. It can, spin around. It can, see if it can identify something. So the sensors we're going to be working with. So for the funny fact, in 2018, the SumoBot actually won using almost no sensors at all. You see some on the sides, but the actual program in the end ended up using only edge sensors. So it only had a little LED and a little photo sensor on the bottom of it to see if it was at the edge of the mat, and it could turn around and keep going and yada yada. But I'm going to encourage you guys to actually use sensors. So the sensors we're going to be using are going to be ultrasonic sensor. Do I have some to demonstrate? I think I do. This is actually the winning sumo bot from a few years ago. And the ultrasonic sensors, they look like those two little microphone thingies there. And we'll learn more about what they do. In essence, they use sound to track objects. They're kind of limited in, you can only see like basically the nearest object at once, at one given time, which is a little annoying. But we're going to use edge sensors. We're going to use ultrasonic sensors. Also, if you guys want to opt for the more expensive infrared sensors, we can learn how to do those as well. They're actually, I think, a little easier than the photo sensors or the ultrasonic sensors, because how do I say this? The infrared sensors are more expensive because they have a tiny bit of circuitry inside of them to kind of smooth it out. So sometimes it's like gets false negatives, false positives here and there, and we're gonna false negatives, false positives here and there, and it just kind of smooths that out for you. Instead, if we do it with the photo sensor, the picture I showed earlier, we have to do that smoothing for ourselves, and it's a little challenging. Nothing too crazy. You basically, for anybody with any math background, we just take a ton of values over a period of time, and then we just take an average of that. It's relatively simple. The ultrasonic sensors are preferred for tracking objects, such as other sumo bots, and the infrared sensors are better at detecting the edge of things, but there's definitely infrared sensors out there that can detect objects. What else can I add? Hot little cheats that you can do in the sumo bot competition. Cotton and other cloths absorb ultrasonics. So if you cover your robot in like a little Swiffer duster pad thingy, just put that over top of your little sumo bot, it can absorb ultrasonics and other robots can't see you. Funny little thing and little quirks about sumo bots. And of course, the little Swiffer little covers that you use, it is flexible, so it won't add to your width at all when you put it inside the little 10 centimeter box thing. Yeah. Yeah, should I? Can you use all the sensors at once? Yes, you can. There's not a damn thing stopping you from using all. Usually, in terms of saving on time programming, you would use like something for detecting edge and the other for detecting objects. It's a little more in terms of efficiency, but if you could definitely go all in. Like, for example, my sumo bot actually only has infrared sensors on it, kind of to keep it simple, but I'm going to definitely, I could add some ultrasonics if I so see fit. And I'm going to teach you guys ultrasonic definitely, and I'm going to do the photoresistor LED kind of method, because I assume most of you guys are going to take that route in terms of purchasing, but if other people have the infrared sensors, I will also provide info on that. Yeah. Well, I mean, I can start modifying this code a little bit. For one, if I bump this up to 255, and I start the simulation, instead of doing the -128, also I switch directions at the same time. You now see it's like 244. Like I said, it can get up there. And then, 255, and then we can make it go nice and slow by, of course, stop simulation. to 60. And it's nice and slow. Of course, you guys can do that with your own code as well. I think, should I add another motor is the other question. I think that could be interesting.
Why not? You got extra pins, 10, 11.
That is true. I could go for it. Do I want to challenge myself? Yeah, we can stop the simulation, copy paste. Adding a second motor, it's pretty easy. Once we got that. So there's also output 3 and 4 and input 3 and 4, and we're going to take advantage of that. So output 4 goes to the motor, output 3 goes to the motor. That goes to input 3 or input 4, and input 3 goes to the Arduino, very similar to the other motor. Also going to color these. We're going to go pink, hot pink. And yeah. And now we need to, of course, modify the code. So motor A and B are technically for the first motor, so we're going to add the define statements. Again, if you forget, the define statements work like a find and replace, similar to Microsoft Word or whatever. If it sees motor A anywhere in the document, anywhere in your code below here, it'll replace it with a coordinating pin. So in this case, I'm modifying this to be motor A, B, and then we're going to go C, and we're going to go D for the other outputs. But if it sees motor B, it'll replace with 6, because the way the Arduino translates that's 6. If you use 6 over here in analog right, it understands that as pin 6, pin 5, and so on and so forth. So now, of course, we need to add more in the setup. Well, it knows motor A and motor B are outputs. Of course, now we need to tell it that we need motor C and D to be outputs.
Wait, don't you also need enable 3.4?
I forgot enable 3.4. That is correct.
You could probably
Thank you.
you could probably for now just put it to pin 9 also.
Yeah, since we want to turn on the whole chip at the same time, might as well. We're going to just go pin 9, and we're going to connect that to enable 3.4, because those are actually separate. Yeah. Thank you for catching my error before it snowballed. And motor C and motor D, you kind of see the pattern. It storms pretty quickly. And yeah, we're still, pin 9 now is controlling both all 4 motor outputs to just turn them on. And then we're going to go down here, and we're going to, what I'm going to make it do is I'm going to make it turn on the first motor, turn it off, turn on the second motor, and then turn back off, and then go back to the first motor. We can definitely have all 4 running at once, but this is just how I'm going to do it. If you want to challenge yourself, if this is something new to you, you can definitely try and do that. But I'm just going to copy and paste the code, and then we're going to modify it. And so we're just going to switch, I'm going to switch motor C and D, and then C and D again. I'm also going to make it go in the opposite direction, because why not? And 28. It's one of my favorite numbers. 128. And we're going to start the simulation and see what the hell happens. Oh, look at that. Look at that. And it works just like that. And it takes like seconds to do. Hopefully nobody's stuck. Definitely ask questions if you want. Always here. Yeah. I don't think. I'm thinking about what to add to this. So in terms of motors, I mean, we can start experimenting with sensors if we want to go down that route. I could, let's see how quickly a SumoBot can assemble just in like an hour. Ultrasonic. Oh, look at that, an ultrasonic. What? Incorrect one. We're using this one, which has 4 pins here. Man, I'm just keep adding stuff. Again, you don't have to follow along. This might get too complex. We're going to have a dedicated tutorial for ultrasonic sensors, and we're going to have a tutorial for, again, the infrared. And I encourage you guys to buy your parts as soon as possible, but if you want to wait till next meeting, it's okay. What I'm going to do is put it up to a vote, I think. Should I do a physical in-person, like I'm going to set up a little camera, I'm going to set it up and build the robot in front of you guys, or just continue with Tinkercad, because if you guys don't have the parts, we can't build along with a physical in-person thing, and it's just best to continue with KiCad. So it's really if you guys acquire parts then or not. It's definitely okay if you want to wait till next meeting next week, so you can ask more questions about acquiring parts once you're like almost about to press order. Probably the best idea. And also, one thing I totally forgot to add, if you guys cannot afford parts like at all, like $80 is just way too out there, you can come and message me on Slack and we can try and sort something out. I don't want to discourage that at all. Should have probably told that earlier, but definitely. Oh, we don't need 3D printed stuff. No, because what we're going to do is we're going to print stuff for you, and we're going to do some kind of handoff. Be it if you're in the GTA, we can definitely deliver, or we can do some kind of, kind of COVID handoff, like. And yeah, me and Adam both have printers. I have 2 myself. Adam has 1 himself.
I have 1, yeah.
Yeah, and we're gonna try and sort that out. Of course, 3D printing we're not gonna do right away. That's kind of a later step. And probably into November, we're gonna start CADing. And since the SumoBot competition is happening a little later, we have more time. So like 3D printing might take place over winter break if you can get it in before then, or into January. So we have time, but we're still finalizing some details about how much filament we're going to buy, yada yada. And yeah, if our group is small enough, I would definitely encourage everybody to have, unmute their microphones and just join the conversation. Probably in future meetings though, because you're all going to try and be building these together. It's going to be amazing. I don't know. We're probably going to close the meeting. I don't know how long, Adam, do you think we should give him for more questions?
I don't know, 2-3 minutes. However, I mean, you can always ask us on Slack. So
yeah, the SumoBot chat is always there. You don't message me privately if you have a stupid question about SumoBots. You can definitely message the chat, because I guarantee other people are going to be questioning the same thing as you. We're all learning, and I can answer them right in the chat there, and it'll help encourage other people to voice their questions as well. Of course, if it's more logistics wise, I can definitely answer privately, but yeah. Ask more questions. I think we're going to finish the tutorial here. We'll give it a few more minutes. And yeah, I'll announce the next meeting hopefully soon. And yeah.
Yeah, just hopefully we'll have, we'll be able to just fill out the surveys I posted on the SumoBot channel, so that we know which time to do the meetings. And I think we'll pick whatever works best for Luke, obviously. But
yeah, I mean, again, I have final say, but I really definitely want to go with majority, since basically every weekday after 7 works for me. So it shouldn't be a problem.
Okay. Yeah, and of course, if you want to look back, we will post the recording on Slack. The staff will post it.
Yeah, so you can hear, I can hear my annoying voice all over again.
I think
Super
we should
fun.
honestly, if we're gonna do Sumo on Zoom, we could probably record them all.
Yeah,
You're okay with that?
definitely.
I mean,
Yeah, I'm prepared for that.
so we have we certainly have an unlimited Google Drive now, so it won't be a space issue.
Actually, how much storage do we have allocated on the Google Drive?
The